This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video we will look at addition and subtraction of complex numbers. So complex numbers are written in the form a plus ib, where a and b are real numbers and I is equal to the square root of minus 1. The complex numbers came about as a tool to solve a problem whereby Italian mathematicians were looking for a formula to find the roots of a cubic polynomial. And to do this, they needed to define, invent, or discover the imaginary and complex numbers. If a complex number z equal to x plus iy, the real part of z, which is defined by the squiggly r of z, is equal to x, and the imaginary part of z, which is the squiggly I of z, is equal to y. So we can see that z is equal to the real part, which is x, plus the imaginary part, which is y, times I. So some examples of this: 2 plus 3i is a complex number where 2 is the real part and 3 is the imaginary part. Now we notice that 3 being the imaginary part, we don't include the I. So when we say the imaginary part of a number, we don't include the I, we just include the coefficient of the I, whatever that may be. 2, which is a number we're all familiar with, can be represented as a complex number as 2 plus 0i. So the real part being 2, and again, the coefficient of the I, the 0, is the imaginary part. 3i, a solely imaginary number, can be represented as a complex number as 0 plus 3i, 0 being the real part and 3 is the imaginary part of the complex number. So if we want to talk about addition and subtraction of two complex numbers, we take two complex numbers, z1 is equal to a plus bi and z2 is equal to c plus di. When we add or subtract these together, we add and subtract the imaginary parts and the real parts separately. So z1 plus z2, we have a plus c is equal to b plus d times I. And we notice that we've added the real parts of z1 and z2 together, and after that we have added the imaginary parts of z1 and z2 together. So let's look at an example. 7 plus 3i plus 2 minus 5i will give us the real parts of the numbers added together, 7 plus 2, plus the imaginary parts of the numbers added together, which is 3 minus 5. And to do this then, it is a case of just adding integers together, which we have seen in a previous video. We get 9 minus 2i. So that was adding two complex numbers. Let's try and subtract a complex number from another complex number. We'll take 7 plus 3i minus 2 minus 5i. This is equal to, again, 7. Instead of a plus, we will have a minus 2. And we have minus 3 minus minus 5. And this other minus comes from the minus in the middle here, where previously we had a plus. We now have a minus, so we need to carry this minus inside the bracket. Now 3 minus minus 5, as we've seen already, a minus and a minus will give us a plus. So we end up with 3 plus 5, which is 8, as we can see. So 7 minus 2 minus 3 minus minus 5 times I is equal to 5 minus 8i.